Welcome to this machine learning case study. In this video, we will be talking about the paper Rapid Assessment of Heavy Metal Accumulation Capability of Sedum alfredii using Hyperspectral Imaging and Deep Learning by Liu et al. Phytoremediation is a method of decontaminating heavy metal polluted soils using hyperaccumulator plants that extract high amounts of metals from soil. The discovery of new hyperaccumulator plant species comes with many difficulties. Complexities in species identification, lack of sampling standards, time, labor, and resource consumption, and cost and safety concerns during elemental analysis. The authors of this study wanted to construct a visible and near-infrared hyperspectral imaging-based method assisted by self-designed multitask deep learning networks to 1. Screen an accumulating ecotype of cadmium zinc hyperaccumulator species Sedum alfredii, 2. Assess external heavy metal stress, and 3. Examine heavy metal accumulation in the leaves. Now a little bit about visible and near-infrared hyperspectral imaging. Stress affects the interactions of light within plant tissues and biochemical components, leading to variations in spectral characteristics. This can be used to study the structural and physiological information of plants. Plant phenotype can also be used to assess external heavy metal stress and environmental pollution. This method may be useful in screening for plant metal accumulation capabilities. During the plant cultivation phase of this experiment, two contrasting ecotypes of S. alfredii were hydroponically cultivated in solutions with varying heavy metal concentrations. The accumulating ecotype highly tolerates and accumulates zinc, cadmium, and lead. The non-accumulating ecotype has a low ability to tolerate and accumulate metals. During hyperspectral image creation, leaves were scanned over two spectral regions, 414 to 1017 nanometers and 874 to 1734 nanometers to create raw hyperspectral images. During hyperspectral image processing, data was calibrated to eliminate environmental and instrumental influence, and images were processed to separate the region of interest from the black background in order to extract the spectral data. During reference determination, leaves were microwave digested and characterized via inductively coupled plasma optical emission spectroscopy to determine reference metal concentrations. Two data analysis steps then followed. First, train and select suitable models for binary classification, multi-label classification, and multi-output regression tasks. Then, the method for sensing ecotype and heavy metal accumulation in S. alfredii was established. Two one-dimensional convolutional neural network-based architectures were self-designed. These two architectures were ENet, which is a shallow network for ecotype identification, and HMNet, which is a multitask network for heavy metal stress and accumulation prediction. ENet was found to be an effective binary classification model, accurately distinguishing the accumulating ecotype and non-accumulating ecotypes within S. alfredii. From these confusion matrices, you can see that ENet on the far right made correct predictions for all the samples it was given, and according to the evaluation metrics, it was the best behaving model. HMNet successfully addressed multi-label classification and multi-output regression tasks simultaneously, and was able to predict the presence of external cadmium, zinc, and lead stress and the concentrations of cadmium, zinc, and lead in leaves. This table shows that the coefficient of determination, or R squared value, was closer to 1 than the other models. The root mean squared error, or RMSE, was lower for HMNet than the other models, and the residual prediction deviation, or RPD, was higher than the other models that HMNet was compared to. To conclude, the spectral approach to screening for hyperaccumulator plants provides an effective alternative to conventional screening. This method only requires a few minutes to gather extensive plant phenotypic data and deliver preliminary judgments through trained models, which significantly reduces time, labor, and material resources as compared to traditional field sampling and elemental analysis. If you are interested to learn more, you can find the paper at this full citation. Thank you for watching.